will explain how to find the critical points and relative maximum and minimum of a function using the first derivative test. So the function given is like this. So the first, we need to find the first derivative. So I differentiate the function to find the first derivative. So the first derivative will represent the gradient of the function. So to find the critical numbers, we need to equal the fx prime to equal to 0. So after that, I factorize the equation to solve it. Therefore, the critical numbers are x equal to -2, -1.5, and x equal to 1. Next, I use the first derivative test to determine whether the function is increasing or decreasing. I divide the numbers line using the critical points and choose test value in each interval. So, when fx is negative, the function is decreasing. When fx is positive, the function is increasing. So, we can say that the function decreased, then increased, then decreased, and finally increased again. To identify the relative maximum and minimum at x equal to -2, the function changed from decreasing to increasing, so it is a relative minimum. At x equal to -half, the function changed from increasing to decreasing, so it is a relative maximum. At x equal to 1, the function changed from decreasing to increasing again, so it is another relative minimum. In conclusion, the function has two relative minima at x equal to -2 and x equal to 1, and one relative maximum at x equal to -half. Thank you.
For question C, we need to differentiate the equation first. For x to the power of 4, we will get 4x to the power of 3. For 2x to the power of 3, we will get 6x to the power of 2. And for -3x to the power of 2, we will get -6x. And for -4x, we will get -4. And for +4, we will get 0. To know whether it is decreasing or decreasing, we need to substitute the values we get from question B. Next, for x less than -2, we will let x equals to -3. So we need to substitute -3 in the equation. And we will get the answer, which is -40, which is less than 0. So the function fx is decreasing, which is decreasing on -∞, -2. Next, for -2 less than x less than -1/2, we will let x equals to -1. So we need to substitute -1 in the equation. And we will get 4, which is more than 0. So the function is increasing on -2, -1/2. Next, for -1/2 less than x less than 1, we will let x equals to 0. We need to substitute 0 in the equation. And we will get -4, which is less than 0. So the function is decreasing on -1/2, 1. And lastly, for x more than 1, we will let x equals to 2. So we need to substitute 2 in the equation. So we will get 40 as the answer, which is more than 0. So the function f(x) is increasing on 1 infinity. So the answer is f(x) increasing on -2, -1/2, and 1 infinity. And f(x) decreasing on negative infinity, -2, and -1/2, 1. That's all for part C. So this is the graph for question D. A rectangle are being lengthened at the rate of 2 inches per second, while the other side are shortened in such a way that the figure remains a rectangle with constant area A equal to 50 inches square. What is the rate of change of the parameter P when the length of an increasing side is A 5 inches? Okay, firstly, you guys can draw a rectangle here, and then since it says that 2 parallel sides, which means the parallel side is, we can put any variable. In here, I'm choosing x as the side that the increasing side, and y is the decreasing side. Okay, and then you guys can list out the data given from the question. A equal to 50 inches square, dx over dt equal to 2 inches per second. Okay, and the question asks what is the rate of change of the parameter. The rate of change, so means dp over dt equal to what? Okay, so it says when the length of an increasing side is 5 inches, which means x equal to 5 inches. Okay. Okay, firstly, you guys, from this area, A equal to 50 inches square, you guys can get an formula. A equal to xy equal to 50. So y equal to 50 over x. You guys have to differentiate the equation x dy over dt plus y dx over dt equal to 0. Based on the information that we have obtained, you guys can just substitute y equal to 50 over x and dx over dt equal to 2. We get dx over dt equal to negative 100 over x squared. Okay, back to the question. It asks what is the rate of change of the parameter. We want to know what is the dp over dt. So we have a perimeter equation. P equal to 2x plus 2y. Simplify it to open bracket x plus y. And then we have to differentiate this equation become dp over dt equal to 2 dx dt plus dy over dt. Since we have all the information, we can just substitute in this equation. So dp over dt equal to 2, dx over dt is 2, and dy over dt is negative 100 over x squared. And then we simplify it, become 4 minus 200 over x squared. And we can just substitute the x for it become 4 minus 200 over 5 square equal to negative 4 inches per square. That's the answer for part A. B. What is the rate of change of the parameter P when the length of increasing side is 10 inches? So x equal to 10 inches. We can just use this formula right here. So it becomes dp over dt equal to 4 minus 200 over x squared. And we substitute the x, 4 minus 200 over 10 square, and we will get 2 inches per second. That's the answer for question B. C. What are the dimensions when the parameter ceases to decrease? Okay, the parameter will ceases to decrease when the rate of parameter is equal to 0. So we know dp over dt is equal to 4 minus 200 over x squared equal to 0. We can move the 4 to the right side, and we will left with negative 200 over x squared equal to negative 4. We cancel out the minus, and then we left the x on the left side and move everything here to the right side. And it will become x equal to sec 200 over 4. And then we will get 5 sec 2 inches. Since it says that they want the what are the dimension, we have to know the value of x and y. So we can just substitute the x into the y. So y equal to 50 over x, 50 over 5 sec 2, and we will get 5 sec 2 inches. So the dimension is equal to x equal to 5 sec 2 inches, y equal to 5 sec 2 inches. That will be our final answer. Thank you.
Question 3. The total cost of producing X radio per day is 1 over 4 x squared plus 35 plus 25. And the price per set at which they may be sold is Rm50 minus 1 over 2x. A. What should be the daily output to obtain a maximum total profit? B. Show that the cost producing a set relative minimum at that output. So we are given the cost function. The total cost of producing X radio set per day is 1 over 4 x squared plus 35x plus 25. The price per radio set is 50 minus 1 over 2x. After that, we have to calculate revenue function. Revenue is equal to number of unit multiplied by price per unit. So
the revenue function is x multiplied by 50 minus 1 over 2x. When expanding and we get 50x minus 1 over 2x. A. Finding the maximum total profit. Profit is defined as Px equals to Rx minus Cx, which is profit equals to revenue minus cost function. So substitute the expression, which is 50x minus 1 over 2x minus 1 over 4x squared plus 35x plus 25. After simplify, we get negative 3 over 4x plus 15x minus 25. Next, we differentiate the profit function. To find the maximum profit, we differentiate and we get this one. After that, we find the critical point. The set the derivative equals to 0. So after we solve, we get the x equals to 10. Since the coefficient of x in px is negative, the profit function open downward. Therefore, the profit is maximum at this value. So maximum profit occurs when 10 radio sets are produced per day. B. Showing cost per set is a relative minimum. Cost per set means average cost, which is cost per set over x. After that, we substitute the cost function, which is ax equals to 1 over 4x squared plus 35 plus 25 over x. After simplify, we get 1 over 4x plus 35 plus 25 over x. Next, we differentiate the average cost. So, we get 1 over 4 minus 25x squared. Next, find the minimum point. Substitute x equals to 10 at this equation. So we get the answer is 0. The derivative change from negative to positive, which means the average cost has a relative minimum. The cost per set is a relative minimum when x equals to 0. Therefore, the cost per set is a relative minimum when x equals 10.
Question number 4, we have to evaluate each of the following limit using L'Hopital. This is formula for L'Hopital rule. This rule is incredibly useful when we encounter indeterminate forms in limit, which means we can directly substitute the value into the expression. For the first one, we got 0 over 0. The derivative of sine 3x is 3 cos 3x, and the derivative of 4x is 4. So we have to substitute x equal to 0 into the new expression, and we got 3 over 4. In the second problem, we have infinity over infinity. We actually have to apply the rule twice because the first derivative still leave n on the bottom. After the second derivative, the exponential term on top keep growing while the bottom become constant. So the limit goes to infinity. For the third problem, this is product, not a fraction. So to use the rule, we move x power 2 to the denominator as 1 over x power 2. After differentiate, we simplify the complex fraction to get negative x power 2 over 2. So when we substitute 0, it gives and we got 0. For the last one, be careful, L'Hopital rule only work for indeterminate form. Since infinity is just a very large infinity, we can conclude the answer is infinity immediately without extra step. So for this question, L'Hopital rule cannot be applied because the limit can be evaluated directly.